So, welcome. Second attempt. For some reason, every time I close OBS, it completely loses the YouTube setup, and I have to sign in again from YouTube. And it's like super annoying, but here we are. Let me quickly manage my chat. This is also here, and I hopefully miss as little as possible. Audio is also there. That's amazing. So, welcome. Welcome, Patsimir. Welcome, Mr. Desai. Slight 3 minutes delay, but I think this is still okay. Cool. Yeah, I'm quite excited for today because it really starts looking like something that can work. And today I definitely want to finish all the mechanics. Wiring, I'm still waiting on a package with more of this like um, 4-wire silicone thing. So I don't have enough wire to do all the motors, but I think that's fine for today. We will just use some temporary cabling from the Ender cables. And so basically, what is the to-do list? The to-do list is we need to install the lead screws for Y. There are two. Of course, also we have to install the motors. It's kind of like speak for itself. We have to install the now I forgot the name of the bearing. The bearing here on the motor. That basically we cannot push the shaft into the motor. The same we have to do on Z. And we forgot something. That's something I realized like yesterday. There are a couple of nuts in this block here, where later the second half of this like clamping mount for the router basically threads into. We forgot the nuts. So we quickly have to take this off here, insert the nuts. So we have to deconstruct a little bit the Z-axis. I don't think this is too bad, but yeah. And then there's some screws missing here on these brackets. And then I think mechanically it should be done. The good news is, like last time we had a lot of issues with this Y motion, and yes, we have picture and sound. Oh, and I also fixed the colors of this camera here. For some reason, there was like some super high saturation applied. So I just removed that, and I think now like the colors, like if you compare my hands, the color doesn't match perfectly. Like this one is a little bit brighter, but it's good enough for me. It's super, like it's a lot of pain to like match different cameras color-wise, and I'm not good enough for that. But yeah, this one works very well now. It's relatively loud, but I think it's just like tons of ball bearings rubbing over the rods. I'm actually not quite sure why this didn't work well last stream. I didn't do anything, to be honest. The only thing is I tried it only with the top rods, so only with 2 bearings here, and it still wasn't good. Then I tried with only the bottom rods, and it was similarly bad. And then I put all in, and after like a little bit more like back and forth, like it just worked. I have no clue. If something wasn't quite aligned, I was at some point also considering if because I have this extrusion here, if this extrusion has an incorrect width, basically pushing like that these two, if you like look at it from the front, basically that they're not straight, but they're like something like this. And that's why it's not running smooth. But like I can't really tell you, but it just works. So good for me. Well, let's get rolling. No time to lose. I think the best thing is to start with this setup here. That also means, or that does mean, if that cable comes out, that we have to take this top plate off because the motor is attached from the bottom. And thrust bearing, that's the word I was missing. So basically we have to install a thrust bearing in between here. So it's a bit of like taking stuff apart, but eventually we will get there. And if everything goes smooth, and this is a long shot, like especially knowing me, but I do have an industrial vacuum cleaner here. we could technically make some cuts. I did prepare a little bit, or like small hello world text that we can engrave. But yeah, it's a long shot. I'm really not sure if we get this far, to be honest. Yes, and here's the end stop cable. So we need to be a little bit careful with this one. Maybe I can just put this here. And we have to reapply thread lock on all these, of course. Bit of a shame that I didn't have the thrust bearings when we built this. Comes apart relatively nicely. And here, the spacing is relatively big. So my idea here was basically to just use like 2 thrust bearings stacked. So it's like always this like washer with a little bit of a groove. And it's like this like bearing with the little balls. And then like the same washer on top. And oh yeah, one is actually totally forgot that. So one of the washers is a little bit tighter. And I think this tighter one is the one that should be on the shaft, so not on the bottom. So this one here can spin. And this one is a bit more tight. And then before, like, there's no need for that, of course. It's just like I don't have any other spacer. I mean, technically, we could just like throw washers there or something. But I have a lot of these thrust bearings, so let's just throw a second one on. It really doesn't do anything. It's just for spacing this out. So basically, here's now without the thrust bearings. Like now, if I press here on this coupler, like it's completely fixed. Like it will not go anywhere. Without the thrust bearings, so I'm now basically I can press in the shaft. Not sure if you can see this on camera, but I can literally press this in here. You see how it goes down. And this is the same that this coupler would do. Like if I now tension this, like so I'm tensioning this now intentionally off the thrust bearing. So there's a gap here. So if I now push on a coupler, meaning I push on the lead screw, the whole thing goes in. And that's of course like a position error that we don't have in our like part, and that's not good. So basically here in the set system, it would mean like you could push the spindle up like 2-3 millimeters. But if we now put this directly on top of the thrust bearings, we will add thread lock in a second. That's what I said, and I didn't do it. Now, basically, when I push on the coupler here, nothing happens because the thrust bearing transfers the force not on the shaft, but like onto the housing of the motor. So now, like, you cannot pull, you cannot push. Like, this is like completely solid now. Okay. Then, as I said, we need to apply thread locker here again. And I think from all axes, that is the one I the least want anything to come on. Because a Ravenkeeper who designed this mentioned at some stream that for somebody like the coupler came loose on that and just the spindle like just dropped down and like cut into the subframe. Looking at this, I think we didn't apply thread locker yet because I knew we would install the thrust bearings. So using quite a healthy amount here. There's a flat spot on the shaft, so let's make use of that and Install it in one screw in the flat spot. I forgot my kitchen towel. Okay, let me grab kitchen towel because I already made the mess here with the thread locker. 1 second. Here we are. Otherwise, I smeared it everywhere. Okay. Then let's just try to drop this back onto here again. But also these screws, I want to have a thread locker on actually. Let me just quickly pull this like little piece off here, then I can just put a bit on the tips here. It's even easier to just leave it on. Okay, and then the direction is this. Okay. For the ones in the back, I don't use thread locker. Those they go into plastic. Well, not directly into plastic, but the heat insert. Okay. Actually looks good. We just nailed the distance here. There's not really like any extra space, so it's good. Just push the for this one I actually want to use like a better screwdriver. Like these small ones are nice because like they're very easy like to use and everything, but you cannot really like torque something down that much. It's like with this one, like you have more grip. I think this is one of these screws where like, especially because it's like metal on metal, like it's good to just like give it some extra. Okay, perfect. So that's this. Then we need to quickly take off the front. Let me see if I can maybe also give you like a little bit of a nice angle here. What kind of screws do we have here? Should be. Yeah. Did we not put all the screws in here? I think we never put all the screws here. Oh, I'm a genius, of course. The lead screw is, of course, on the back, and we cannot really like. So this is, of course, connected to the lead screw. There we go. This is what held it in. Okay, so there are a lot of screws here. And these are the four nuts that I mentioned that we did not apply yet. So let's quickly throw nuts in here. And I'm kind of like considering potentially it's best to just use the lock nuts there. Because I think I do have M5 lock nuts. Exactly. And they fit perfectly. So these are these like nylon nuts. They have a little bit like this blue nylon ring, which also prevents the screws from coming loose. I think this is a perfect opportunity to use those. And that was all we needed to do here. It's good we revisited that. Yeah. Because now seeing that we didn't tighten the stuff down here, that is not very helpful. Okay, so we lost the bearing. And it's easier to just do it like this. And we can tighten these down here again. Oh, well, that did not work. Seemingly the lead screw was not yet inserted in the coupler there. So I screwed the, or like, yeah, screwed the nut, screw completely through the hole. Let's try this again. All nuts are where they're supposed to be. Oh, also looking at this now, which if I can, oops, show this. Let's see, we need something shifted here, because now I can do this again. So I think we also have to loosen these here. Make sure this is fully to the top. Yeah, no, it's good. Okay. And now we only have to put these back in. And this time with a bit of thread locker. And we also have to line it, of course. Although the rails should be parallel already, so I don't think there's much we need to do. I'm not sure if we anticipated that we take this apart again, and this is why we didn't put the thread locker in, or if we just forgot. Both are equally likely. Let me also grab more of these screws. Wondering if these are 8 or 10. 8. Yeah. This one doesn't want to go in. Maybe it's best to not fully tighten them yet and just like leave it a little bit loose. Let me see if I can get the screw out. I do get the screw out. I could try a different one. To check if something off with the screw. Yeah, this one is okay. But this one doesn't want to go in. Am I retarded? I already put the screw in there. There's already a screw in. Time for weekend. Time for weekend. Yeah. Let me make sure they're all tight because these are loosened again. And then we can align these. Yeah, Mr. Design, this is my feeling. This is like a random M310 again here. Like I feel like I had that before. Some point, some M310s must have. Oh wait, I see the. I see the issue. I think there were like a couple of screws still in. Because also here there's one hole where there's still a screw in. I think. Why does it not come out? There's not a screw in, and I think there are two. They going to be. I don't know why it doesn't fall out. Slides all the way forward and then doesn't come out. What is the screw? Well, this one's the same. Like here you go. Thank you. Yeah. Also there are two. Okay. I'm just. Okay. So we need to be careful with this. Why? I mean, of course. I. Okay, that should be the last one. Okay, cool. Perfect. Then, just to make sure we don't lose these nuts in here, I would just quickly fire in some screws here. Okay, perfect. Then, that should have been everything we needed to do on that. Yeah, and that's not completely solid. So the next step would be the y-axis here. Similar thing we need to do. So we need to install the thrust bearing, which hopefully should be okay. You can't lose them there behind the rail blocks, everything. Oh, it's true, Steve. Yeah, if I have a long enough screw, I can get them. But like, better safe than sorry. Okay, so this has the same setup here with the thrust bearing. And looking at this, I think we also double stack that. Like these thrust bearings are also incredibly cheap, so. And welcome, Steve. So this one is the one that's a bit tighter. So this one is loose. And for this one, doesn't matter because it's just to space this out. Okay. Then thread locker. Pushing this one now down just to make sure it's all the way down. And actually, let me rotate that. It doesn't really matter too much, but I prefer having them on these flat spots on the shafts if they have flat spots. Yeah, for some reason I can't really push this in. Not sure where this is now hanging. That is the end that I cut with a saw, so was that somehow squeezed into the middle? No. Ah, okay. Well, that was the problem. So these screws somehow like deform the coupler somehow a little bit. I don't know. And then before we push this onto there, let me add a little bit of thread locker to the here too. And I'm missing one screw. Oh no, there it is. Let's make sure the connector is to the bottom, and then we can. A bit awkward here with the rods. Tighten this. Okay, that should be good. And now, like, we cannot push this in anymore. So that is the same fix applied. Cool. Then that is the y-axis, which leaves us with no, it's the x-axis that leaves us with y. And in the end, it's exactly the same thing. I did cut the lead screw just before the stream, so they are now the correct size. I did properly tighten this one. Oh yeah, and these are like these three printer couplers, and they have a little bit of like a spring in here, like they have this like half cut and cut here, and that allows them to flex a little bit. And the ones I have are like solid brass, so they don't have this flexing. Oh yeah, before we forget this, let's see how we do that. Because last time I didn't have enough of these lead screw nuts. and there are two missing here. So we still have to fiddle those on. And the interesting part, but I think the only way to do that is to quickly remove the back corner here. And yeah, I think it's the easiest to remove the back corner and slide off the whole carriage. Luckily, that's only 4 screws here. And these I didn't tighten yet. So technically this should just, yeah. Come off. See if I can show you this again from here. But technically I can just pull it off completely. Now we could have done that before, that would have made our life a little bit easier, but hey. So you see here, there are the 2 heatsink inserts. Get this back open. We want to install the lead screw nut in here. I think last time we figured it's easiest to just use a lead screw. And push this in. And then we basically just screw the lead screw through here. And there's a certain distance these 2 nuts have to have. So now basically it's through both. Make sure we align the holes here. Okay. And now what we can do is basically we can tighten down this nut, and then the 2 nuts will squeeze the lead screw from 2 sides, and this will eliminate any backlash that we have. We just have to be careful how much we tighten that, because if it's too tight, and thread locker is very important for this one, then we basically that's the wrong top and bottom. If we tighten it too much, you will not be able to turn the lead screw anymore. So this is like a very much like a delicate thing to adjust. Yep. So the following, I just quickly like thread that through here. And it's a lot easier to tighten these screws. Now you see like it's basically stuck, so I have to like back this off like half a turn. So now it's okay to twist. There's a little bit of backlash here now. Yeah, now there's no backlash, and I can still turn. Okay, that's one side. Let's do the second side. Sure, if that was not smart, you didn't have to. Oh, great. And cut myself a bit on the sharp end of the lead screw here. Let me quickly grab a plaster, otherwise I smear stuff everywhere. 1 second. Problem solved. Okay. Then let me put in 2 screws. I think it's something to do spare maintenance. The nuts will definitely wear out over time. Yeah, that could happen. We also have to add some grease to those nuts for sure. But it will also like very much depend on how much you use the machine, right? Like, I mean, this is not a machine I will run like every day. There's a little bit of like crusted thread lock here. I have to clean that. But it's exactly the same design as the Milo CNC. I think I cannot leave this one open during the stream. Let's just dry it out a little bit. Okay. See, so this is like way too much now. trying to get them like somewhat equal. I think this side is just a little bit like harder than the other. I think it will be okay. Okay, then let's put it back together. And how I always do that is I put the rods in one by one to prevent pushing the rod in with tension, because then it's easy to uh, knock some bolts out. Okay. One side in. And that is the other side in. And now we can just put this in. And when everything is aligned, it goes together. Okay. Also here, let's add some thread locker. Oh, that was a bit too much. And these screws we can do later. They're not really essential. It's just something I added here. And we can continue. Let's first do the motors. This one definitely screws easier than this one, but it will be fun. Okay, so here's the motor. The shaft here is shorter of these motor types, so we only need one thrust bearing. So here, let's just make sure to push this down. And these motors don't have any flat spots on the shafts, which is not really needed. Because like the lead screw also doesn't really have a flat spot or something, so that is perfect. It fits. So the other side, and then we do the screws to hold the motors. And then I think the last thing we need to do is the end stop, the Y end stop. I'm not sure if we have two end stops here. Looks like two end stops. Which makes me wonder, do I have two more end stop switches? Because I think I only planned with three end stops. Oh, that's the wrong order of things. And we also need the thrust bearing, of course. Okay. Just have to like adjust it quickly, like the position. Only thing is now we have to kind of move that forward. When it gets to the screws. Okay. Good morning. Can't wait for the motors to work here. I don't have to do this by hand anymore. Okay, let's quickly check. What kind of screw do we need here? I assume it's relatively short. Yeah, the M10, M310s here are perfect. Let me just. This might not be the perfect order of things here. Shit, my screwdriver doesn't fit in here. Hmm. We kind of have to do this in this order, I think. Because the motor has to be the last to do on this. This screw is not really cooperative. Otherwise, this motor also is only on 3 screws. I wonder why this one. So 2 inner screws don't want to slide forward. Right. These two are there. Okay, so it's definitely like open hole. I wonder why this will not go in here then. Like somewhere in the hole, the screw gets stuck. Okay, let me see. But yeah, we kind of have to do it like this because like we kind of loosen this coupling here. Well, we can remove one motor to make it a little bit easier. We can give us a little bit more working area. See. So I don't need all 4 screws, like 3 is enough. Okay, let's really remove one motor completely because then I can just put it vertical. Maybe that helps with the screw falling in. I do have M3 reamer, but I guarantee you the problem is not the hole diameter. Like this fits. Like this is 3. This is not a problem. I don't think that's a problem. Just now I put again like a screw on a screw. It doesn't line up. That's the problem. Let's try it like this. See, now it's. I don't know why the screw doesn't go through there. Like these two are no problem. It's only the inside ones. Okay, let's take this one off again. God knows what the problem there is. This would be half as annoying if you wouldn't have to thread in the stupid rod. Maybe I should connect the motor first. And everything is like nicely lubricated. Quick back. This is how it worked. Okay, we're almost out of the first nut. Okay. Yeah. I will not do that again. Okay. I have no clue. It doesn't work. A fuck. Okay. I have no clue what is up with this stupid hole. It's not like that the screw doesn't fit through there. Okay, whatever. There's a thread in the. Does this screw, this one here, partially block it? Fuck me. Yes. This screw blocks the hole. Like not fully, just like a little bit. That's the problem. That's why it doesn't go in. So that is something that would need a manual. Okay. Doesn't matter which one. Yeah. Then on the other side, it's exactly the same problem, most likely. I don't want to take this off again. Now this can most likely just go back in. Exactly. So the order matters here a lot. Fun. Let's remove this dreadful. But once these are in, I think that's the last mechanical thing we need to do, right? Plus the end stop switches, which we will now install while it's off, just to make our life a little bit easier. Okay, yay. Then I have one end stop switch here. You see if I have a second one loose. Otherwise, we have to cannibalize the ender end stop switches. We only have the bigger ones, so we have to quickly take apart one of the ender switches. But then let's just do, to keep it similar, use two of the ender switches. Let me quickly see. So I do prefer the ones with a little like metal edge over them, and these two don't have that. But this one does, and this one does. Okay, then we have to quickly take those apart. What else could we see where I put the rest of the cable we had? I could have sworn we had some extra cable. Yeah, this one was long enough. I think we still had a little bit of this cable left. Or did we use it all? If we use it all, we have to quickly see which cable to use. Seems like we used it all. Then we will cannibalize some cable from the ender. Or did I put that here? Nope. Then we have to take from the ender. Okay. Oh, I also need my solar pump. Technically, we can also just snip it off, maybe. Let's do that. There's no need to desolar this. We can just snip the legs off. And there's a teeny tiny screw we have to get rid of. And then we have a switch. Let's quickly do that again. Okay. Just bending these legs straight. And then we need cable. So we need to be a bit careful what we cannibalize now, because I also want to use these ender cables as temporary stepper cables. So here are 2 stepper motor wires and 1 very long end stop cable. Then we can use these 2 for the motors. I have 2 more cables here, so then we have enough stepper cables for everything without making our own for now. And let's just be lazy. Let's keep this end. It doesn't matter. We have to, for now, we need this end. So I'll just, let me see if I halve that. I wouldn't halve it. One should be quite a bit longer than the other. Something like this. Because later the connection to the main board will be on the left side. So one cable needs to be longer. And that's on the right stepper motor. Okay. Let me quickly add a little bit of tin to those. Smart people would have put the soldering iron already to like more degrees. Okay. And then we need to put the cables through. And let me think. No, this one needs to be the short one. This one is the short one, and this one is the long one. And I get rid of something if we don't need it anymore. Very well soldering joint. Yeah. I completely smashed the cable here. Like the cable got the isolation got too hot. It doesn't really matter because it's an end stop cable and this will be in here. So this does not matter. Let's make sure this fits in here. Yeah, nice. Because this switch is again wider as the hole, so we need to make it a little bit thinner. Tiny bit more. And it's also a bit too tall. Here we go. It's the end stop switch. Now we have to repeat this one more time on this side. I assume it's the same fitment issue, yeah. Hey Adam, welcome. Oh, still a little bit too tall. That makes two end stops. This cable is perfect length. This one is too long, like we later have to shorten it, but now it's fine. That was everything we need to solder, luckily. Quickly clean up. Let's see if we can get this bad boy together. Because at this point, we can technically just start seeing if it moves. Okay, so this one doesn't go into the forward nut for some reason. Let's see. Yeah, no, it's. I think the trick is like I'm hanging it now off the table here, because like here the it doesn't sit flat, of course, because the corners are not in. Okay, another interesting part is like you have a lot of like different things that you thread into. So this one is definitely not aligned, and this one as well not. Yeah, maybe it's a good idea to have all the rods on the back. Now everything's on the back. Really not sure what the best strategy here is. See. So where does it touch? Yeah, this is not super hard because this is very close to the end here. See, everything is like roughly the same length. So it's like everything kind of threads into each other at the same point. So the rods are in all four. That's good. Then this one. Okay, we're getting somewhere. Ha! It's in. Perfect. I think the last bit was the rods here. This one is 1 millimeter longer than this one. I didn't cut it super precise, but good enough. Okay, let's lock it in. And I hope I don't have to take this apart for some time. Whew. That's it. That is it. Perfect. So these two are conveniently crimped. We actually need one switch with the 3 pin thing. And This is our electronics case for the people that still remember. So this cable we can get rid of. So these are two motor cables. And just like for ease of use, so like I kind of want to wire this up and like test it out now. We have two motor wires here. So let me already wire these two up here. So that gives us two. These are the Y motors, which we plug into the last existing slots here. Then what is labeled E, if I remember correctly, is X. It's a bit of a mess. So that also goes here. Then end stops. We need to figure this out. I just plug in one in Y. And then the one with the 3-pin. It's a little bit like close with the cables. We have one 3-pin end stop here. Just works cable-wise. And that leaves this one here, which is technically this motor. Like we can plug it in for now. We just need to be careful. No, let's not do that. I'm the first person moving that in a bad way. Can we also make this like this? That makes these cables a lot easier. Then, what we need to do then, basically, this is the end stop Y. X. I always get it wrong. Then also coming here from the drag chain is the Z end stop. And that leaves this cable here, which is currently unterminated. And that is the stepper for Z. So I would quickly crimp a cable on here, because then all the steppers are hooked up in an interesting way, but they are hooked up. And then we should be able to move everything in all directions. Exciting. Yes, and this cable here, this is the Z that we will now use the proper cable for. Just need to see like if our crimp motor cable is correct, but it should be potentially it runs backwards, but that's not the biggest problem to solve, so that should be fine. Let's see, where's my... Ooh, this is literally the last I have. Interesting. So that definitely should be on my order list. So I already prepared the enclosure for this thing. Like I already posted it on the Discord, and I think it looks pretty nice. So next week we will most likely start rigging up the enclosure with LEDs and everything. And then you kind of see it here on the back. I can tell in a second. So this electronics box will be connected with the enclosure with three 24 AWG Ethernet cables, basically. So it's very easy to then remove this electronics enclosure, which will be outside of the CNC enclosure, where all the dirt and dust is. If I want to transport it or something, it's very easy to detach. And we have these like breakout boards. I'll show it in a second. With which everything is connected. So basically we will create these breakout boards next week with the final cabling. One, two, three, four. Perfect. Now let's say, let's see what happens. Just to quickly show you, this is breakout board, I mean. So it has an Ethernet jack or RJ45 jack. And here we can add a JST header, basically. So we will have like a 9-pin JST, 3 9-pin JST, where all these cables from the device basically connect to. And then we will have this little breakout panel here on the side where everything connects. So they basically, that goes in like this. Other way around, but like this. And then we have the 1, 2, 3. And this is a control connector. This will go to our control panel that we then build at some point in the future. Not too far future. So that will be 24/7, I think. Let's give this some power. So we need to be a little bit careful here with cable lengths. Especially this one here. So it's a bit of a stretch. I don't think, yeah, we need to be careful. I think we need to be careful. This is what I think. But I think this one here is a shorter cable than this one here. So let me quickly swap these two. Yeah, that gives quite a bit more reach. So if we put this on the side, let's put this cable behind here. And fire. Yeah, this cable here is a little bit, if this would be longer, it would be a lot easier, but it is what it is. Okay. Um, Carla. This is Carla. Oh, I didn't plug in the cable here. My bad. And there is a thread locker on the cable. Not sure if thread locker works with cables. Let's do some checks. So we have 3 end stops that are open and 1 that is triggered. Let's see. So I think Y1 is this one here. Yeah, this is Y. Wait, can I have a small preview. So this one is Y1. This doesn't work yet. And this one is Y. And then I think this one here is, of course, X. And I could double check this works. Yeah, this is X. And then Z also works. So for Y, we need to see Y not. And Y is the plug with 3 pins. So we basically have one end stop to use like a 3-pin connector, which seemingly is Y1. And end stop pin is PA4. Okay, let's just put a pin in that for now. I want to quickly stepper bus. Stepper bus. Stepper equals stepper Z. So this should be this one. Yeah, I mean, you don't see it from the camera, but buzzing it is. Then we want stepper X. This should be this one here, so you should see this wiggle a little bit. Yeah, I see it wiggle. So this is good. Then stepper Y, which is this one here. Yeah, wiggling it is. Very little, but it does. Oh, but this is Y. So these two are swapped. The steppers are off, so I can pull the cable. Never pull the cable if the stepper is energized. So let's try Y1. This should be this one here now. Yeah, that is this one here. And then Y should be this one here. Yes, this also does. So all the steppers work. That's great. For that, 50-50 chance it runs the wrong direction, but that's something we can fix in a second. So the only thing we need to look at really is this end stop cable here. And I remember this was a 3-pin thing, but I'm not sure which one is PA4. And I don't think we had a pin out of this board. I think we said these eyes and something at some point, but it was like a schematic. I do have this one here from Ravenkeeper. And that's how I plugged it in, like X, Y, Y. But the X one we swapped, I remember that. It's just a question if the plug is correct here. Because now I have it in on the outside pins. Not sure if I have to connect it to the center pin. It would be great if Ravenkeeper could be here, but he's busy eating cake, I guess. Let me think. Technically, it's just a shame that we don't have a proper pinout of this. Is there a pinout? This is like not the pinout I need. I need the proper pinout with the configuration I downloaded. These are schematics. But this is the schematic. Uh, but this is what I need. You making chips today? I no, I don't think we make chips today. Like there's a little bit like more work needed, but like we are close. We are close. I mean, if I could read this, it's definitely the two outside pins. Like this one here is 3.3 volts. And this one, the center one, is this like, is this a PDF? Can I download this PDF that I don't see a preview? Download. Oh, nice. I can download it. Now, can I zoom it? Yes. Perfect. Okay. So this one here goes to 3.3 volt. The center one goes to ground. And this one here goes to PA4, the outside one. So my configuration here with a stepper should be correct. It should work. I hope the solder is not bad, because this would be like absolute pain to get out now. Let me quickly jump the pins. No, it's a config issue, because now I'm electrically connecting the two pins, and it definitely doesn't do it. So this must be something config-wise. I need ground and PA4. Let me double check which one is which. Because I don't want to connect ground with with 3.3 volts, ideally. So I need to remove the one on the side of the other ones, which is this one. I need my knife. Where did I put my knife? Oh, I see it. 1 second. And this one goes to the center now. And then this should work. If I press it, nothing explodes. So yeah. Thank you, Mr. Design, and hi there on. So that means technically we can home stuff. Let's see. So first let's home that. Then we need to see if the motion direction is correct. Yeah. So that homes. Perfect. Then let's home X. Somebody said this board would be super loud. Like my steppers are not loud at all. Now the interesting part. Why? I don't want to home Y directly. I first want to make sure that both steppers move the same direction. So set kinematic position. Y is 150, whatever. Now you see it jumps here. Y is homed as far as the printer is concerned. And now I can move 1 millimeter basically. And just to see that like it goes the same direction. It does. But also what I notice, it doesn't move a millimeter. Same reason we had on the other things, the rotation distance is off. Because this config is for the normal Ender CNC, but we have the Rodmod Ender CNC. So the rotation distance is set for belts, not for lead screws. And now I'm confident that we can do a home all. It homes in the wrong direction. But it moves. Let's see. So end stop position is not 266. Let's just put this to 400 for now, then we can later figure out the position. Position min is 0, I guess. Whatever. No, that's 0 here, and then the end stop position is 0, and then the homing direction is, I think, automatic. Let's try again. It homes a bit too far. Is it moving in the right direction? No, it's not. You're right, Mr. Rees. I incorrectly corrected it. The max velocity is quite high here. Home. Homing speed 70. Hell no. What do we have there? 20. And the end stop position is 400, of course, here. Which also means the direction pin on Y and Y1 needs to be inverted. Okay, so now it should still home backward, but then it thinks it's at 400 and not at... Yes, and now it says 400. It's hot. Okay, let's just see. No, now I screw up. This was too much. That was too much. Okay, let's try homing again. We also still need to lubricate the lead screws. Does it not actually trigger both end stops? Yes. Okay, so we need to have something. Oops. And 2. So I'm just trying to find like what actually the distance is that we can set the end stop position correctly. That is 400 minus 33. So it's not 400, but it's 367 then. The only thing that's not concerning per se, but like it's a little bit like it's like a millimeter off here on this side compared to this side. So it's not perfectly square here. Okay, then let's lubricate the lead screws. I think that's also important to do. I'll just squeeze on a little bit lubricant. And we do the same here. And then we can just go to Y5 something. Let's also add a little bit of lubrication here on the end. And we can go back to 365. And we can do the same on X. I just don't know what the max of X was. Oh, 260, okay. Just my Creative 42 word was loud as hell. But the Red 42 can either have TMC 2208, like 427 soundboard, or loud A98. Well, this one definitely has 2208s. Like from the sound, like it's good. I'm just not sure how much lubrication I need here. I will add a bit more, just for good measure. I don't think you can have too much lubrication in this case here. It will grab all the dirt from milling, yes. That's why we'll have vacuum. Okay, let's do also a bit on that. I think this is good. Oh, I forgot on that. It doesn't go all the way up. Oops. Now it's smeared like lubrication here on the. Well, the nut will never reach there. So, are we close? Okay, cool. Yeah, that is pretty good. I would take this as a cutoff point for today. It's moving in all axes. So the motion system is completely done. So next time I would mount the spindle, not like spindle. It's not a spindle, but it's one of our trusty Makita routers. And before I use the machine, I want to clean the wiring up a little bit because this is not really nice with the short wires. So basically next time, I'm not quite sure if we put it in an enclosure already, but we will definitely wire up all the breakout boards and have the final wiring basically done. And then we can also do add the router here. And that's something I still have to print. Like there's a dust collection shoe that we will also mount. And then I think next time I am almost certain that we will have some chips. Depending on how long we take to crimp all the cables, because this is quite a fair bit of crimping in the end. I mean, for these, we can reuse the plugs we already have. We only have to recrimp one end. Motor cables, we have to crimp a couple. But yeah, it shouldn't take too long. I think maybe like an hour for all the crimping and stuff, and like cables. And then this will relatively quickly mount, because it's literally like 4 screws, right? So there's not much that can go wrong here. And then dust collection shoe. Maybe we leave that off for now. Also just to see like what is going on. So test speed macro, we can do that. Honestly, like it already feels a bit scary, like how fast it moves now. I'm actually not quite sure what the speed is. So something like I can change. It's never something I changed in control. Ah, yeah, so it's 100, so it just runs at the max speed, I think. So let's just put this to 25 as well. So if I now go to 0, it should go tiny bit slower. The motors do get toasty. The motors do get toasty. That's a little bit concerned with the PLA maybe. This one not. This one not. The small ones get toasty. Let's see what we do about that. I need to see an enclosure. I don't have tons of space. I do have. Let me see where I have that. Ah, these. So that's an option like these, like cooling heatsink. I mean, God knows if I get these two apart ever again. That's, I think, a task for some. Ah, here we go. I mean, this is something we can do. But the enclosure is very tight, size-wise in this direction. So I'm not sure if we have the space for that. We might just, maybe not. So let's see. This might help a lot. Concern here is basically with the motors being warm. This is PLA. There's also like an option I thought about because I have anticipated that might happen. There's also an option that we use like cork panels in the NEMA 17 shape, basically, just to isolate the motor from the PLA. That like basically heat of the PLA from the motor doesn't transfer to the PLA directly, but that we have some isolation there. Because like if this works for a while, I don't want the PLA to get toasty here. Cool. Yeah, but then let's cut it off here. And then next week we do all electronics, and hopefully next week we can start cutting some stuff. That would be really cool. So with that being said, enjoy your weekend and see you next week. Bye.